two straight pipes with radii 1 and 1/4 lie parallel and in contact on a flat floor. The figure below shows a head-on view. What is the sum of the possible radii of a third parallel pipe lying on the same floor and in contact with both? So first, let's see what the third circle or the third cylinder is going to look like. There are two possibilities. Either the third cylinder is going to be right here, tangent to the other two cylinders as shown by the red circle. The other possibility is that the third cylinder is going to be outside, as shown by this yellow circle. If we were to extend this line. So we want to find the sum of the radii of these two circles. Now there are a few ways to do this. You can use the Pythagorean theorem to find the radii individually. However, there's a pretty nifty way to solve this problem using Descartes' circle formula. So this is not a very well-known theorem, but it can help a lot on this problem. So before we describe what this formula says, we first need to define the notion of curvature. So the curvature k of a circle is defined to be the reciprocal of the radius. Now, in the statement of Descartes' circle formula, the curvature can either be positive or negative. Positive if a circle is externally tangent to the other three circles, as in this case. And negative if we have an internally tangent circle that circumscribes the other three circles. Now, the idea here is that we're going to think of this line segment, or this line on the bottom. We're going to think of that as an infinite circle with infinite radius. Therefore, its curvature is 0. So this means that the curvatures of the circles are going to be 1, 4, 0. And then we don't know the curvature of the fourth circle, so let's just say that it's k. So what Descartes' circle formula states is that if we have 4 circles in the plane that are mutually tangent to each other at 6 different points, the formula states that the square of the sum of the curvatures of the circles is equal to twice the sum of the squares of the curvatures. And so we can see that if we know this formula, this will make this problem very, very quick. So by plugging in what we know for the curvatures, we see that 1 plus 4 plus 0 plus k all squared. This is equal to 2 times 1 squared plus 4 squared plus 0 squared plus k squared. So this will simplify to 5 plus k all squared. This is equal to 34 plus 2k squared. So we can expand this and get a quadratic equation and solve for k. We will find that k is equal to 1 or k is equal to 9. These are the two solutions. This is going to imply that the radius is the reciprocal of k. So r is going to equal 1 or 1/9. This will imply that the sum of the radii is going to be 10/9, which is choice C.